So we're going to go down our checklist, and this will be given to you for exams. So first we want to find any vertical asymptotes by setting our denominator equal to 0. So I have 3x plus 1 equals 0, 3x is negative 1, x is negative 1/3. So I have a vertical asymptote, which I normally shorten to VA, at x equals negative 1/3. Next I need to check for other asymptotes. Okay, let's start with A. If the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, my numerator is degree 0, and my denominator is degree 1. So my numerator has lesser degree. I have a horizontal asymptote, which I tend to shorten to HA, at y equals 0. Now I can stop. Because my numerator has lesser degree than the denominator, it's not going to have the same degree. It's not going to have exactly one more than the other. So we can stop. Once we meet either criteria A, B, or C, then you stop. Let's work through another example. I have f of x equals x plus 2 over 4x minus 1 times x plus 5. I'm going to go ahead and set my denominator equal to 0. Now I can use the zero factor property to pull these factors apart and set them both equal to 0. As you can see, I'm going to have two vertical asymptotes. I'm going to have a vertical asymptote at, you have to solve this first, x equals 1/4 and x equals negative 5. I'm just solving for x. So I have vertical asymptotes, and I can have two, that's okay, at x equals 1/4 and x equals negative 5. Now my denominator I know is going to be degree 2, because if I multiply this together, I would get 4x squared plus 20x minus x minus 5 all over x plus 2. And I could simplify that by combining like terms. But I need to know the degree of my denominator. Let's find our other asymptotes. If the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, my degree of my numerator is 1, and the degree of my denominator is 2, so it is going to have a horizontal asymptote at y equals 0, and I don't need to check the remaining criteria. Next, let's go ahead, start out first by finding our vertical asymptotes. So I set my denominator equal to 0, and I solved. So let's add 6 to both sides. 4x equals 6, divide both sides by 4, x equals 6/4, but this isn't fully simplified. We always want to simplify all of our fractions. So I get x is 3/2. Friendly reminder that this is the value excluded from our domain. Our domain is all values of x such that x doesn't equal 3/2. Because this value is excluded from our domain, it's our vertical asymptote. That's how the two are related. So our vertical asymptote is x equals 3/2. That's a line that my graph will not cross because x can never equal 3/2 or I'd be dividing by 0. Now we check for our other asymptotes. If the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. Well, my numerator is degree 1 and my denominator is degree 1, so they have the same degree. My numerator isn't lesser than the denominator, so I can move on. It's not criteria A. B, if the numerator and the denominator have the same degree, then the functions of this form, which it is, then the horizontal asymptote has the equation y equals their two constants. So I've got 2/4. So I have y equals 2/4, which we want to simplify to a half, right? We always simplify our fractions. So I have a horizontal asymptote now not at y equals 0, woohoo, actually at y equals 1/2. That's the line my graph will never cross. Next, I have f of x is x squared plus 1 over x minus 3. So the first thing I always want to do, find our vertical asymptotes. We set the denominator equal to 0. I get x equals 3. My vertical asymptote is at x equals 3. And remember, that's the value excluded from the domain of this function. Now we determine our other asymptotes. If the numerator has lesser degree than the denominator, then there's a horizontal asymptote at y equals 0. So I've got degree 2, degree 1. We don't meet the criteria for A. For B, the numerator and denominator have to have the same degree. Well, that's not true. They don't have the same degree, so it's not criteria B. Let's go to C. If the numerator is of degree exactly 1 more than the denominator, there'll be an oblique asymptote. Well, I agree that 2 is exactly 1 more than 1. So what we need to do is we need to divide the numerator by the denominator and disregard the remainder. Friendly reminder, I need a placeholder so that every degree of x is represented. So what do I multiply x by to make it look like x squared? That's x. X times x is x squared. X times a negative 3x is negative 3x. I subtract this. My first terms cancel. Get a positive 3x and I pull down my plus 1. What do I multiply x by to make it look like 3x? That's a 3. 3 times x is 3x. 3 times a negative 3 is negative 9. We subtract and we disregard the remainder. So this, I don't care about that 10. So my oblique asymptote is at the line, right? That's a linear equation. Its slope is 1. Its y-intercept is 3. Y equals x plus 3. Let's talk about the behavior of graphs of rational functions near their vertical asymptotes. So if my function is even, like when we looked at 1 over x squared, this would be like, then it's going to be having the same behavior. They're going to be approaching the vertical asymptote together. If it's odd, like when we saw 1 over x, they're going to have opposite behavior, just so you know.